Okay, on page 11 it says that it wants us to write each of these quadratic equations in the form y equals a blah blah blah, which we know is vertex form, without using technology, okay? And notice it did not say we need to complete the square. So if they don't say we need to complete the square, why do it by completing the square? That is the most painful form possible, right? So let's find the vertex. If we find the vertex, we can easily write vertex form, right? The only difference between this page and the last page is that each one of these equations has an a, which the others did not. Okay, and maybe you don't know what I'm talking about, but I'm going to show you why that's a little bit different in a second. Okay, so first thing we're going to do is we're going to find the vertex. Okay, that's going to enable us pretty much to write it in this form, except for this a, which we'll come to later. It says to find the y-intercept. We'll review how to do that, the same as last page. Finally, sketch the quadratic. And once you know the y-intercept, once you know the vertex, you can pretty much sketch it. Okay? Use technology to check your answers. I'll show you how to do that too. Alright, so let's take the first one. When you find the vertex of this, remember, first you're going to find the axis of symmetry because that gives you the x-coordinate of the vertex. Negative b is going to be negative 4, right? There's a, so 2a is going to be 2 times 2, which is positive 4. And negative 4 divided by positive 4 is negative 1. So we just found that the axis of symmetry is negative 1, or the x-coordinate of the vertex is negative 1. Now, how do we find the y value? We can find the y value easily by just plugging negative 1 in for these two x positions, and once we do that, we're going to have the y value that corresponds to that x value, which means the y-coordinate of the vertex. So 2 times negative 1 squared plus 4 times negative 1. Notice I'm very careful about using the parentheses because negative 1 quantity squared is not equal to negative 1 squared, right? This is going to be negative 1. This is going to be positive 1. They are not equal to each other. That's why I'm being really careful about putting parentheses around each of the terms I'm substituting in for x. Here I have 2 plus negative 4 plus 5, which is equal to 3. So our vertex for part A is going to be negative 1, comma 3. So now we pretty much can write it in vertex form. All we need to do is write y equals, and we don't know a, so we'll just leave a, and we'll put x minus a negative 1, which is x plus 1 squared, and then plus 3, which is plus k, right? The only thing we don't know is a. But we do know a, because the a, when you do vertex form, is the same a as when you have standard form. So this is one of the only things that standard form is kind of immediately useful for. If you look at standard form, you see that the coefficient in front of the x squared is 2. That happens to be the same a value that you're going to use for this form also. Isn't that handy? It's also the same a that you would use in factored form if you use factored form. Okay, so we just did we found the vertex, we found the equation in vertex form. How do you find the y-intercept? Well, the y-intercept, all you need to do is put x equals 0, and then out pops the y-intercept. So if you put 0 in here, we know that the y-intercept is going to be 0 plus 1, 1 squared is 1, 2 times 1 is 2, plus 3 is 5, okay? So you notice that the y-intercept is not just 3, because this is not the same thing as the c value here. It's the k value. The other way you could do it is you could look back at the original equation, because the original equation does tell you the y-intercept immediately, because the c value is the y-intercept. Notice if you put 0 in for x here and here, these two terms disappear, leaving only the c term, which is 5. Okay? So we just found the y-intercept. Now it says to sketch the graph. Okay, so to sketch the graph, we're going to use the fact that the vertex is negative 1, 3, and the y-intercept is 5. We could also use the fact that it is negative 1, 3 would be there. I didn't draw my axes very straight. Y-intercept is 5. It's right there. Sorry, that disappeared for a second. Technical problems. So I'm going to redraw this axis here because it's not exactly on the line. That's better, isn't it? Okay, now, so I know that the vertex is here. I know that the the y-intercept is 5. So that means that this is also at 5 because I just reflected it, right? The parabola is obviously symmetrical, okay? And one thing you're going to notice about this parabola is it is not a standard parabola. Remember that a standard parabola starts at 0, goes to 1, then goes to 4, and then goes to like 9 or something, right? So it has a certain slope to it. It's not really a slope, but it's like an incline. So you can see that this one, if you say that this is 0, the second step is 2. The third step is actually going to be something like 8. Okay? So this is much more sloped than the other one. And the reason why is because the A value for this, of course, is 2. It's not 1. Okay? So 2 means it's going to be taller or narrower. Okay. So finally it says to check your answer with technology, so I'm going to show you how to do this briefly. Okay, and maybe you'll see now why we don't spend too much time with the calculator, because it's basically the same procedure for a lot of different functions. I'm counting on you to use it enough on your own that you can remember how to do these things. Okay, it's pretty easy. You just go to the y equals screen using the y equals button to input the function. You may input the function like this. You may input the function in vertex form, whichever. The calculator doesn't really care. Okay, so I'm going to put 2x squared. Squared, you could use this button here, or you could use the caret and 2. I'm going to put plus 4x for x. X, you're going to use this x here. You're not going to use the green letter X, which is somewhere down here. Okay, I don't know where it is, but somewhere down here. You're not going to use any other X. You're going to use the X that's right here. 2 over and 1, or yeah, 2 over and 1, 1 over and 1 down. And then you're going to put plus 5. Okay, so we put in the equation. Then we're going to graph it. Okay. Usually for a lot of these simple graphs with like small numbers, the standard zoom is fine. Okay, if you happen to be in a weird zoom, the way you can get to standard zoom is you press zoom, and then you go to zoom standard, which is 6. Okay, you really need to use your calculator frequently to get used to different kinds of zoom. A lot of people have trouble getting the window to how they want, and it's just experience and practice that's going to get you there. So I have it graphed. It looks kind of like what I have here. If I want to make sure that it's the same, one way to do that that's easier is maybe second table. You go to second table, which is blue key here, and then table. And then you can, oh, and look, my table's all screwed up. My table has all these weird decimal numbers. So how do I fix that? This is a good thing that this happens. So I'm going to put second table set. If I put second table set, it shows me that the table is starting at 2.5 and is jumping by 0.25. It should always start with starting value of 0 and a jumping value of 1, a step size of 1. And if you do that, then the table is going to look more normal. And, oh, you know what it is. It's like in a, it's in like a scientific notation mode. So that's why it looks so bad. This is good that we're getting all these weird displays, so you can figure out how to fix your calculator when it gets in a weird position here. So you go to mode, and then I'm going to say, I don't want scientific notation, I want normal. So you click on normal. Your calculator is probably not going to do this, just so I did a different problem for another class, and that's why it's like that. So now I'm going to do second table again for the last time. And oh, okay, here's it. It's nice. 0, 1, 2, 3, 4. 5, 11, blah, blah, blah. Okay, and so let's check the values here. 0, 5. Is that right? 0, 5. That's right. It was the y-intercept, right? What about the negative 1, something value? What's that? Negative 1, 3. Negative 1, 3. Yeah, that's right. And then I'm going to finally go up to negative 2, 5, and that's right too. So I checked my answer with technology. Okay, make sure that when you scroll up, you're in the X column, because if you go to the Y column, you'll notice that it does not scroll up. Okay, it only scrolls up if you are in the X column. Alright, so I successfully checked my answer with technology, and now I'll move on to C and E. So let's do C. C has an A value of 2, a B value of negative 6, and a C value of C. Again, we're trying to put it in vertex form, so the first thing we're going to do is find the x coordinate of the vertex, which the easiest way is usually to do negative b over 2a if you're starting with standard form. So I'm going to put negative negative 6, which is positive 6, right? Divided by 2a, which is 2 times 2, which is 4. So I ended up with 6 divided by 4, which is 3/2, okay, also known as 1.5. Now we'd like to see the value of y that corresponds to that x coordinate of the vertex. And we can do that just by plugging the x value 1.5 into this equation. So we get 2 times 1.5 squared minus 6 times 1.5 plus 1. So that'll give us 2 times 2.25. You can put that in your calculator and make sure. 6 times 1.5 would be negative 9 plus 1. So that would be basically 4.5 plus 1 minus 9, which is 5.5 minus 9, which would be negative 3.5. So our vertex turns out to be 1.5 comma negative 3.5. If we were going to write vertex form, we would write y equals, and we put the a value seen here above, 2. So it would be 2x minus 1.5 squared minus 3.5. Where did the negative sign come from? Here. It comes from here. Why is there a negative sign here? Because the standard form of vertex form has a negative there. So you put the negative there if the x-coordinate of the vertex is positive. It's kind of hard to get used to. Okay, so there's our vertex form. And the other thing we need to do, which is pretty easy, is to find the y-intercept. Remember that the y-intercept can be found by looking at the c value of the standard form. Don't look at the c value of the, or there is no c value, but don't look at the k value of vertex form, because that is not the y-intercept. Okay, it is the y-coordinate of the vertex, which is usually going to be different than the y-intercept. Okay, so the y-intercept is going to be 1, so we already know the y-intercept is 1. And so now we have probably enough information to go ahead and graph this. And I started out graphing it wrong, so that's why it's wrong. Let's see. So we're going to graph the vertex, which is going to be 1.5 comma negative 3.5. So it's going to be 1.5 and negative 3.5. So it would be about there. The y-intercept was 1, right? So from the y-intercept of 1, we can also predict that the right side reflected value is going to be right there, right? Because I'm reflecting it along the axis of symmetry here. So now I can already pretty much draw it. It looks like that. All right? Okay, and now let's move on to E. So E. So with E, we can see that the A value is a little bit different. There's nothing there, but actually it's a negative 1. So the A value is negative 1, the B value is 4, and the C value is 2. And so if we want to find the x-coordinate of this vertex, we're going to say x equals negative b divided by 2a, which is 2 times negative 1, which is negative 2. And so that gives me positive 2. Negative 4 divided by negative 2 is positive 2. Then we're going to find the y value by putting it into the equation. So negative x squared plus 4 times x plus 2 is going to give us negative 4. Do you know, since the negative is outside the parentheses, it's not going to get squared first, so it remains negative, plus 8 plus 2. So that's equal to 10 minus 4, which is 6, right? So now we know that the vertex is actually 2, comma 6. And so we could write the vertex form as y equals, and what's the a value again? The a value was negative 1, remember? X minus 2 squared plus 6. So now we have the vertex form, and now we can find the y-intercept simply by looking at the original standard form equation and seeing that the c value is 2. So the y-intercept is equal to 2. So now let's draw that. So we're going to put the vertex at 2, 6, 2, 6, and then we're going to put the y-intercept at 2. So we can see this one is actually pointing down. Do you see how we got this point here? We just reflected it about the axis of symmetry, and that's how we got that. Okay, And now we're going to just complete the drawing here. It's upside down, or it opens down, right? And that's it for E. I'm not going to check these with technology. You already know how to do that. Once you've seen that once, you've seen it for every single function that exists. 5.3. Using the graphing package or graphics calculator to determine the vertex of each of these functions. Hence, write the function in the form vertex form. Okay, so now I'm going to show you how to use the graph of the calculator to find the vertex, which is pretty easy. First thing you're going to do is you're going to graph this function, which is x squared minus 4x plus 7. And then we're going to graph it. And then we want to know where the vertex is. It's right there, actually. And there's a couple ways to do this. One is, maybe you'll get lucky, and if you do second table, and you look at the table, you can already see where the vertex is. And the way you can see where the vertex is if you see this pattern here. Do you see how I have a pattern where there's 2 7s, there's 2 4s, and in the middle there's a 3? Well, if you graph this out, you could see that, like, since there are matching numbers on the top and the bottom, those are symmetrical points on the left and right side of the vertex, and the vertex is going to be this one number that's in the middle, which is 3. Okay, so in the case of A, we can already tell that the vertex x coordinate is going to be 3, and then the y coordinate, the y coordinate is 3, and the x coordinate is 2. So we can already tell that it's 2, 3 just from looking at second table. Okay, and a lot of times you'll be able to do it like that. Sometimes you won't be able to do like that, and the reason why is because maybe if it's slightly off center, maybe the vertex is not on a whole number, and then you can't see it on your table. So in that case, what you're going to do is you're just going to graph it, and then you're going to use a function on your calculator, which will find the lowest point here. In this case, you're looking for the lowest point. The lowest point is the vertex. So you're going to do second calc, and you're going to say, I want the minimum point. And then you're going to say, okay, I know that the minimum point is here, so calculator, I'm going to tell you 2 points around this point to give you a range to look for this particular point. I'm going to give you a point over here, and I'm going to give you a point over here. It doesn't really matter where, as long as inside that interval there is the vertex. So it says, where's your left bound? And the left bound is here. It's to the left. That's fine. So I'm going to press enter. And then ask for the right bound. Then I'm going to use the right arrow to move over to the right side of the vertex. It doesn't have to be this far to the right, but you have to make sure that the real vertex is in between. Then it asks you for a guess. It doesn't really matter what you put because, yeah. So you see it gives you 2.00005. The real answer is 2. Since the calculator uses like a numerical algorithm or a program to find this number, it sometimes doesn't exactly find the number. It gives you a number that's close. Obviously, even if you rounded this to 3 significant figures, which is recommended by B, you're going to get 2, 3 anyway. So we've confirmed that it is 2, 3 using that method. Okay, so let's do C now. So C, we're going to input the equation in here. It's going to be negative x squared. Negative, make sure you use this negative and not minus. Okay, it's different. X squared plus 4x plus 5. And I'm going to graph it. Oh, in this case, we would use second calc max in this case, okay? Let's see if we're lucky enough to see where the max is using second table. So do we see some symmetry here? We do. 5, 5, 8, 8, and in the middle there's a 9. So we know that the vertex is 2, 9. 2, 9. Now we'll do the last one. Okay, so we're going to put negative 2 x squared plus or minus 10x plus 1. And then we're going to graph. Oh, it's off the screen. Okay. First, we're going to see if we can find it with second table. Then I'll show you how to do this case with second calc max. Let's see. Oh, there we go. Oh, there's some symmetry there. 9, 9, 13, 13. But you see there's no point in between. Now, if we use our imagination, we know that the vertex is going to be at negative 2.5. Okay. And you can see the point at negative 2.5 by changing the step size. I could change the step size here by putting plus 0.5, and then it'll step by 0.5s, and then now I can probably see that the vertex is at negative 2.5, 13.5, right? Negative 2.5, 13.5. But there's another way to do it. If you're not like that familiar with how to manipulate the table, you could just find it here. And one problem we have here is that the point is not even in the screen, right? In order to get the point on the screen, one of the ways you could do it is to use window, and I just might want to go a little bit higher up, so I'm going to put a y max that's a little bit higher. So instead of y max 10, which is the normal standard window, I'm going to put y max equals 20, and then I'm going to probably be able to see it. And then I'm going to use second calc max, which is just the opposite. Second calc, second calc, and then I'm going to go to max instead of min, because obviously when it opens down, it's got a maximum, it doesn't have a minimum. The left bound, you need to put it on the left side of the maximum, you hit enter. The right bound, you need to put it on the right side of the maximum, then you hit enter. You notice it puts these little triangles delimiting the interval. And then it asks you for a guess. It doesn't matter what the guess is, you just hit enter. And there it gives us this negative 2.50002, 13.5. And the real answer is negative 2.5, comma, 13.5. One thing that we did not do that it asked it to do was find the vertex form, so we'll go ahead and do that. This is the easy part. The a value here is just 1, so we don't write any a value. X minus h value, which is 2, squared plus 3. A lot of people forget to put the squared. That's a fatal error. Make you lose all your points. The a value here is negative 2, so we just write it there. Then we do x minus a negative 2.5, which is x plus 2.5, squared plus 13.5. And then finally, y equals, and then the a value here is negative 1, so we put negative x minus 2 squared plus 9. Okay? And then last thing here on page 36, 37 reading, it does ask the relationship between the discriminant and the quadratic equation. Well, as you might have noticed, the quadratic equation has b squared minus 4ac inside the radical sign, or the square root sign, and it turns out that this part is the discriminant. Okay? What happens when the discriminant is negative? When the discriminant is negative, you have a square root of a negative number, and if you remember, there are no two regular real numbers that you can multiply together and get a negative number, right? If you want to find the square root of negative 4, what two numbers can you multiply together, or what number can you multiply by itself to get negative 4? There is no such number. Not a real number anyway. So that's what happens. You kind of get no solution.